So we'll be talking about stoichiometry today. Stoichiometry is a concept that a lot of students tend to get intimidated by, and it's a little bit undeserved in my opinion. Stoichiometry is tough and it's got some math in it, but typically what happens is we get a little bit too wrapped up in it, in the complicated part of it, and we kind of forget to look at how simple some of it really is. And one thing that you'll see with stoichiometry is that it's really about ratios, right? So if you're having a hard time really grasping this idea, really try to think back to ratios. Ratios are is the foundation of your stoichiometry. In particular, you'll see we'll talk a lot about mole ratios because, well, we're talking about chemistry, and when we talk about amounts of things, we talk about moles of things. So our ratios will be mole ratios. Some other things that we'll need to think about with stoichiometry is a balanced chemical equation. So a balanced equation. When you're trying to do stoichiometry, it has to be done with a balanced equation in mind. Otherwise, you've got nothing to generate these ratios out of. In particular, and we'll jump over to my equation here in a second, we'll have to think about the coefficients. So what do I mean when I say coefficient? Well, I mean the same thing that I do in math, right? In math, a lot of people would be familiar with 2x. They would say that 2 is the coefficient. It's exactly the same in chemistry. So in front of our H2O, we have the number 2. That's a coefficient of 2. That means 2 water molecules, 2 H2Os, and you have your arrow here. So the 2 H2Os react, and we'll skip the oxygen, come back to it in a second. You have 2 H2s as part of the product. The reason why I skip the oxygen, right, is just to make the point of, remember, in chemistry where we see places where there is a number and there's not, that means you should really assume that it's a 1. So this chemical equation, right, says that 2 water molecules react to produce 1 oxygen and 2 hydrogen molecules. So really what that's actually going to tell us is, we talked about how we need mole ratios a second. Our mole ratios are really just the ratios of our coefficients. It's not explicitly shown in an equation, but these coefficients represent relative amounts of moles. So for every 2 moles of water that react, 1 mole of oxygen and 2 moles of hydrogen are produced. So let's look at kind of a quick little sample problem here. So let's say that we had, let's go with 3.7, there's a decimal point there, moles of H2O react, right? And let's say I want to know how many moles H2 are produced. So it seems like there's a decent amount of information in that problem, and there is. But again, the thing we're really going to come back to is let's focus on the ratios. And that's how we think about this. So if 3.7 moles of H2O react, that's this stuff, I want to know how many moles of H2 get produced. Well, I can figure that out by just using the ratios of my coefficients. So I'm going to look at the ratios between those two substances. And I just need to set them up correctly with some math to make this an easy, reliable way to solve this problem or do this operation. So the easy, reliable way is always start with kind of your actual amount of stuff. Technically, you could start with the ratio first, but I think this is a little bit easier. So 3.7 moles of H2O react. And now I need to use the ratio. So think of a ratio, right? In math, a lot of people like to write ratios with a dot between them, like a 3-to-2 ratio. You put the dots here, right? There's no reason why that couldn't be written as 3/2. They mean exactly the same thing. So that's what we're going to use. We're going to stick with the fraction version of a ratio as opposed to the dots. So 3.7 moles of H2O, I'm going to use a fraction ratio, right? 2 moles of H2O. I want the ratio between my H2O and my H2. It's a 2-to-2 ratio. right? This is my 2 to 2 ratio seen between these two things. So if 3.7 moles of H2O react according to this 2 to 2 ratio, I will produce 3.7 moles of H2. And that would be the answer. And that makes a ton of sense, right? Look back at this chemical equation. For every 2 that react, I produce 2. So if I reacted 1, I'd produce 1. If I reacted 2, I'd produce 2. If I reacted 3 moles of H2O, I'd produce 3 moles of H2. If I reacted 3.7 moles of H2O, I would produce 3.7 moles of H2. It's just using this ratio. The one thing that's a really useful tool to kind of help make yourself keep your ratio right is your ratio is always coming from these coefficients, right? But you got to make sure that you put the right part of it on the bottom and the right part of it on the top. Always put whatever you're coming from on the bottom, right? See how the moles of H2 and the moles of H2, the moles of H2O and the moles of H2O on the bottom and they match? That's good. That's what lets the math work. Mathematically, these units will cancel out, right? And always put what you're trying to find out on the top. So here's what I'd like to have you do. Take a second. All right, I'll draw a nice little line for you here. And pause the video and try to figure out how many moles of O2 will be produced. Same amount of H2O, so if 3.7 moles of H2O react, how many moles of O2 will be produced? Pause the video and give that a try right now. So I'm assuming that you've paused the video and given that problem a try. Let's run through it to see how you did. So like we did in this first problem, right, we're going to start with our physical amount of the substance, right, whatever physical amount we have. That was our 3.7 moles of H2O, right? And we're going to use the ratios between the two things that we care about. And I'm going to put the thing that I already have on the bottom of my ratio. So that's my moles of H2O. And I'm going to put the thing that I want to find out, the O2, on the top. So my moles of O2 on the top. Now, right now I just have units, right? That's not a ratio. I need to put some numbers in there to get a ratio. So I'm going to come up to my balanced chemical equation. I'm going to snag that 2 and put it on my bottom, right? Because the moles of H2O part of my ratio is on the bottom. And I'm going to snag my 1 from my O2 and put it on the top. So we've now set up my math, right? I just got to solve for it, right? It's 3.7 moles of H2O times 1 divided by 2. So what is this? This is 1.7, so let's see, 1.5 times 2 would be 3. 1.75 times 2 would be 3.5. Yep. So that means we need another 0.2. So we're talking about 1 point. Oops, I don't know why I put a 1 there. Did I set it probably? Talking about 1.85 moles of O2. Right? Right. That sounds right. So this is our correct answer for this problem. If you got that, you did great. One more thing before we go. Let's just double check our units, make sure everything canceled out. That's a great check to make sure you did your math right. So remember what we set up here, right? Units that are on the outside and on the bottom, when you're multiplying by a unit and dividing by the same unit, they will cancel out. So we're multiplying by moles of H2O and we're dividing by moles of H2O, so that unit and that unit cancels. That means our moles of O2 is the only unit left, so our answer is in moles of O2.